This is the Cancer and Loss of Cell Cycle Control Lab by Sarah Cirillo. The questions investigated here are: number 1, what happens when infection by a virus or mutagen causes the controls to fail? And number 2, what are the consequences of uncontrolled cell division? With that said, my claim: when infection by a mutagen causes the controls to fail, a disease uprises. And when cell division is not being controlled, this leads to a deformity of cell shape and function. In this case, I will be focusing on the mutation of chromosomes X and 18 that leads to synovial sarcoma. As you can see in my karyotype of synovial sarcoma, most chromosomes are in homologous pairs, with the exception of 4 single chromosomes, 2 of which are mutated, X and 18. Synovial sarcoma is characterized by the chromosomes translocation of the SYT gene on chromosome 18 and the SSX gene on the X chromosome. Resulting from this is a fusion protein, SYT-SSX, which plays a role in the formation of tumors. Contact inhibition is a biological event that prevents cell division from being controlled. And because cell adhesion is important in this event, without it, tumor cells become invasive and metastasized. Synovial sarcoma is a type of soft tissue sarcoma, a rare cancer. Only about 1 to 3 people in every million get it each year. It can occur any time, but mostly in young adults. Oddly enough, it has no biological affiliations with the synovial tissues that are in part of the joints. It occurs mostly in the arms or legs, but can appear anywhere in the body, which is metastasis. Symptoms include difficulties breathing, swallowing, or change in voice if the mass is located in the head or neck region. For many, the mass is painless and deep within the body, or can move locations, which is why it may seem harmless or go unnoticed. During contact inhibition, SYT, when with the nuclear transactivator P300, relays a nucleus to cytoplasm signal that allows the cell to undergo tight adhesion and spread on the extracellular matrix. Interference is what causes a change in the cell shape and its inability to adhere fibronectin. A diagnosis can be evaluated with X-ray, sonogram, CT scan, and MRI for suspicious masses. Then a biopsy of the mass will be taken. If malignant, further studies such as a PET or CT scan will be evaluated for possible metastasis. With that, a treatment plan is outlined, usually a surgical removal of the entire tumor or radiotherapy to reduce the risk of leaving cancer cells behind.